Welcome to Practical Build Management with Gradle course. In the 9th section of this course, we're going to review how Gradle can be customized in order to support our particular needs of our particular project. In this section, we're going to review how to find the right plugin for our needs. We're also going to take a look on the plugin API in order to understand what and how we can create with plugin API in order to support our needs. And of course, we're going to practice in plugin creation. In the first video of this section, we're going to review what is actually plugin, what it does and why we need it. We're also going to overview the sources of plugins that we can use for our projects. We will start from built-in plugins, then proceed to plugins portal, and of course we will take a look at other community resources where we can list plugins for our needs. As we know, Gradle comes with limited amount of functionality out of the box. We actually explored this in one of the initial videos when we apply a plugin and then it brought lots of functionality to our project. And that means that Gradle extends its capabilities through plugins. Gradle provides quite simple but at the same time flexible API to create plugins. There are two types of plugins exist in Gradle. It's a script-based and binary plugins. Script is just a Gradle build file or just a file with extension Gradle that is applied to a build.gradle file. And binary plugins is pretty similar plugins, but they are distributed in a binary format as a jar files, and Gradle is able to download them. As for the functionality of a nature of a plugin, basically there are two phases. One is resolution of a plugin in order to be applied to a project, and then application of a plugin for a particular project. So in Gradle there are two ways to apply a plugin. One is through new plugin DSL and another one through a build script. Plugin DSL has some limitations because it can be used only in build.gradle files. However, using build scripts, we can apply different plugins from different sources. For plugins, we also need to specify repositories from which plugins can be retrieved. Here we can see the definition of application of plugin using old style that is called from build script. So basically there is a closure where we define a repository from which to retrieve a plugin, dependencies, and then application of plugin. So pretty simple. Okay, now we know basic information regarding plugins, what is this and why we need it. Let's just take a look how we can find a plugin for our project to cover our needs. So let me introduce the built-in plugins that are provided by Gradle out of the box. So here is the list of plugins to support programming languages. By default, Gradle supports Java, Groovy, Scala, and Untitled. So support for those programming languages comes out of the box with Gradle. Along with those projects, there are incubating plugins to support other programming languages like Assembler, C, C++, Objective-C, Objective-C++, and Windows resources. So basically those plugins are in incubation phase, and that means that it's the API can be changed, or functionalities that supported by those plugins can be changed in future. There are also a set of plugins to support integration. For example, using Gradle, we can create a Java application or executable jar file, or we can package our Java application as ER file for deployment to application server. We can also use Jetty plugin in order to run write in the command line interface a web servlet container in order to serve HTTP requests through Java servlets. And there are more plugins related to this. There are also some additional incubating plugins for integration. There are distribution of source code or applications as zip or tar files, publishing plugins like Ivy or Maven we actually introduced to this plugin. There are also plugins related to support of software development lifecycle, like checkstyle, for example, to analyze our source code according to guides established for our project, to analyze our code for quality, to provide integration with integrated development environments like Eclipse or IntelliJ IDEA, and many more. There are also incubating plugins. For example, here is a plugin to provide integration of Gradle with Visual Studio and others. And there are some base plugins and third-party ones. Okay, now let's try to take a look at community plugins. Actually, some time ago, Gradle set up a portal for list of plugins provided by community. This portal can be found by this URL. It's plugins.gradle.org, and here we can find lots of plugins provided by community to Gradle. We can list them. There are many more. Basically, we can, for example, see here name of plugin or ID that can be used for application of plugin, brief description, some text related to functionality supported by plugin, plugin version, and update time at which plugin was updated. We also can use search. For example, if we need a plugin for Node.js, for example, we can type it here and we can find a plugin to support Node.js, or we can, for example, choose Node.js as a tag and then try to find it. Or we can also, for example, write JavaScript and then we can see the list of Gradle plugins to support JavaScript. So lots of plugins there. For example, we can navigate to one of those plugins. We can see brief description, link to source code, version, creation date, and how to use this plugin. Along with this registry or portal of plugins, unfortunately not all of them are listed there, so many plugins can be found using just Google, or there is also a pretty useful set of plugins implemented by Netflix and provided as part of the open source initiative. And here is a website nebula-plugins.github.io where those plugins could be found. In brief, there are lots of plugins like creation of the projects and dependency log. For example, this plugin allows us to fix the dependencies of any project resolved by Gradle so that we can see what dependencies are changed, and basically this plugin generates a file that can be committed into the source code versioning system and then can be tracked. And when we can change a version of any dependency, this plugin can highlight this in the source code version management system. And there are plugins, for example, for publishing, for Java doc generation. For example, Nebula provides a plugin to aggregate Java docs from multi-module project structure, where we have a Java doc per each module within our big project, but then we can gather them together in one place and use them as a single source. There is also some useful plugins for releasing and, for example, for uploading to community artifact repository that's called Bintray, or referred inside the Gradle as a JCenter repository. Okay, at this site we can find a useful set of plugins that are ready for any particular project. And of course, as I said, we can use Google to find the plugin. For example, here's Node.js Gradle as an example, and we can see that right in the first line there is a plugin to support Node.js. Okay, that's it about the ways how plugins can be found.